G'day, this clip's a bit of a mix-up. Last week I was working on some television feet and I got the straights cut, but I didn't get or start on the radii. So this week I've got a bit of that. I've also got a couple of other things that I was machining, which I didn't quite get round to, and they're not big enough to put in their own. So this is a bit of a mix-up, but there's still a bit of machining in there and a few tips and observations and all that sort of thing that are probably worth having a look at. Question was asked in a previous video, how do I tram up my mill, particularly when there's a vise on? And the answer is I don't. If the vise is on here and I need to tram it up, I'll take the vise off, and I'll explain the reasons for that in a moment. But my apparatus for tramming is pretty straightforward. This is a Starrett 196 indicator, and these are all parts of the kit. This isn't. This is homemade. But what it means is that I can have this mounted in the chuck, dial that in, and then I can switch around to the other side here, and that's I just trammed this, so that's at 0, and so I can say that is, well, this head is vertical to the table within 1 thou over 12 inches, and that's nice. But it also means that I can see that here, and I can see that when that's over there, and I don't have to worry about mirrors or anything like that, so it makes it rather easy. And what I normally do is I'll zero that, I'll then swing that around, and usually I do it by grabbing the chuck, by the way, just so that I don't disturb this beam, which I just did. Swing that around and then adjust the angle of the head so it's half the difference. And that's all there is to it. Now, tramming with a vise on, as I said, I don't. I have seen devices where people have made up rings and then put them on legs, stood them on the table, and then they tram on that ring. But when you think about what you're doing with tramming, all it takes is a little bit of grit under one of those legs or a bit of swarf or something like that, and it can throw your tram out. So you're better off with a clean table. Even this is a bit dicey because I've got a few dings and things in it, and if I happen to get a ding, then I'd be in strife. However, I do use a broad foot on here, and so that's good enough to avoid most of the dings. So anyway, a Starrett 196 indicator, you can get them in sets with all these bits and pieces, or you can just get them by themselves. But if you're not a Starrett fan, or there are other things out there, I think Mitutoyo make them, Compact make them, but they're called a rear plunger indicator. I've just started preparing a piece, or machining a piece of aluminium, and I thought I'd show you a couple of things. First of all, I've mentioned it before, but I'm using 2 vices here. It's a long, thinnish piece. If I used one in the middle here somewhere, these ends would vibrate, I'd get chatter and all that sort of thing. So if you're going to do lots of long stuff, I would strongly suggest having 2 vices, or having something long enough that you can hold the whole thing down in. I'm using a woodworking router bit here. It's a straight cut carbide, so you will get some straight lines coming up on the cut, but nothing too unpleasant. And the reason I'm putting this chamfer on in the first place is that there's going to be a pivot going through here, and I could put a round on there, but trying to get a round to match up and look halfway decent is actually tricky. You've got to be spot on, your cutters have got to be ground really nicely, all that sort of stuff. Far easier and quicker to put a chamfer on. This one is a 7 millimeter chamfer, and that's a 25 millimeter thick piece of material, so it's 28% of the width. But what that means is that I can have a hole sort of equally spaced from that flat there, that and that in there, and that will give me the maximum clearance, you'd call it, for having that rotate. So something worthwhile to remember, 28% of your width gives you a chamfer that will allow you to put a hole through there and hinge. And I think, from there to there is something like 12.5 millimeters. From there to there is about 13.5. Sorry, to the corner is about 13.5. So not too bad. Two other things to note here. One is that although that's a 7-degree chamfer, I'm only doing about 5 here at the moment. And the reason for that is, I was taught long ago by a woodworker actually, that you're better off doing a cut, leaving a little bit to take off, and then doing a clean-up cut just to give you your better surface. In that particular case, it was a router bit and it was burning in timber, but the same thing holds true to metal. When you're taking a deep cut, you're getting deflections, you're getting all that sort of stuff. So I find you're better off taking a deepish cut, but not to full depth, and then coming along and just cleaning up on the outside to give yourself a better surface finish. The other thing is, you can see here, there's some smearing of metal. Now that's aluminium. And I've talked before about aluminium oxide and wanting to stick to everything, and this is proof of that. This has been done dry. I'm going to squirt that with a bit of WD-40, and that'll disappear pretty much. And that just shows the importance of having a lubricant in there that will stop the aluminium trying to bond to itself. WD-40 is my go-to for aluminium, but any of those sort of light cutting fluids, lubricating fluids, whatever you want to call them, penetrating fluids will do. I just happen to have a bottle of that sitting around the place. This particular piece is a mock casting. I seem to do a lot of those for spare parts and things like that. However, the bit that I wanted to point out on this one was that here I've put a radius in the root here to make it look more like a casting, because a casting would have a fillet in there. And I've got a cutter with a radius ground on it. But what I've done is, when I went in with the square cutter, I left this a little bit, about 0.5 millimetre or so higher than I wanted it, so that when I came in, I could then re-zero this radius cutter on here, take off that 0.5 millimetre, and then go in and finish up that corner. And the reason for that is, if you try matching up a square-ended cutter with a radiused cutter, it's an incredible amount of work to actually get it to match. You'll get a witness groove, or you'll get a ridge across there, which won't look all that flash, and then you've got to do a bit of rework to try and fix that up. So just as a tip there, yes, if you're using a radiused cutter to put a radius in somewhere like that, leave it a little bit high and then just take it off so you get that nice blend into the radius. Here's the finished part. It's nothing terribly exciting. It's a dresser holder for a grinding wheel. Slides in the slot like so to get a parallel face, but it does illustrate the importance of thinking about what you're doing before you do it. So to make this part, I started off with a rectangular piece, then I put in the side pieces, and that meant that I could then hold it in the vise like that to put that bevel on. Once I'd done that, I was able to flip it over in the vise and grab hold of that part and put the what would you call that, the tenon, the guide, the whatever in there. Now, if I'd tried doing that in a different order, if I decided actually I'll get my block and I'll put that bevel on there first, then I'll bother putting those in, I wouldn't have anywhere to hold it. And so a bit of thought does actually help when trying to make these things. If you're ever in a situation like this where you've got a web in there and you don't know how thick it is, measuring is actually quite easy once you think about it. What I've got here is just a couple of bits of metal, and if I zero my caliper there and then put one on either side, making sure that they're properly down, I can then come along and measure that, and as you that's 2.9 thick through there. So that's how you measure a web if you haven't got easy access to an edge of it. This is the jig that I've worked out. It's a bit of angle that I've welded onto a bit of strip, so I've got something to hang on to, and then I've measured up from this face and worked it all out how far I need to come up. So what's going to happen is that will bolt on there, and then I can come in with my cutter and shape that at the appropriate radius. I was going to do that on both sides, but then when I sat down and worked it out, this one's something like an 750 and this one's something like an R500, and so I haven't got the stroke there. So what I'll do there is I'll just dress that with a file. It's not going to be much. This side, if I draw a straight line from that corner to the edge of the foot, the depression there is only around about 1.5 to 2 millimeters. I can't remember the exact number. So what I'll do is I'll straighten that out. Using a round file, I'll file that to the right depth, and then using a half round or something similar, well, a half round, possibly a round, I'll then dress that all back and use a template as well, just to check the shape. But until that witness mark disappears, and that's how I'll do that one. And here they are, my 2 television feet in their near final form. As you can see, the radii worked out quite nicely. I've yet to put the crown on here and the subsequent hollow there, and as I said, I'll just file in a groove 1.5 millimeters thick and then just shape to suit, make up a couple of templates to measure that. But yes, collection of machining bits. Thanks for watching, see you for the next one.